Welcome to this Whiteboard Explainer. Today we're sketching out the crazy mechanical engineering powering modern robotic surgery.
A human hand just can't pull this off, but a robot? Yeah, a robot absolutely can.
So let's dive into this engineering mystery. How exactly does a surgeon's natural hand tremor just vanish?
Well, engineers had to merge the high dexterity of open surgery with the tiny incisions of laparoscopy. The biggest hurdle? Us. Literally every human hand has a natural, involuntary physiological tremor.
Their genius solution is motion scaling. It mathematically shrinks big hand movements into tiny, ultra-precise instrument movements.
So, a comfortable 3-centimeter movement at the console becomes just a 1-centimeter movement inside the patient.
Engineers basically scaled human anatomy down to movements smaller than the width of a grain of rice.
To ditch those shakes, control software uses digital signal processing to instantly filter out high-frequency tremor signals. This creates a continuous real-time loop of sensing and actuating, calculating all these adjustments instantly.
This loop repeats so incredibly fast that any lag is completely invisible to the operating surgeon.
Now this meant engineering a miniature, fully articulating wrist right there at the instrument's tiny tip.
Thin cables and pulleys drive this tiny wrist, keeping the heavy, clunky motors entirely outside the body.
To guarantee precision, dual offset lenses recreate that crucial 3D depth perception you'd lose on standard screens. The result? Highly complex surgeries, safely performed through incisions that are less than 2 centimeters wide. There are trade-offs, though. Surgeons lose direct touch feedback, so they rely heavily on specialized visual training. Ultimately, this tech doesn't replace the human surgeon at all. It just mathematically refines their skill. Which leaves us with a really fascinating question. What human physical limitation will engineering solve next?